Okay, so now we're going to continue with our geometry unit, and this lesson is segment addition postulate. Okay, so what is the segment addition postulate? We're going to talk about that in a bit. So first of all, a postulate is a statement that is assumed to be true without proof. For example, a line contains at least 2 points. We assume this to be true. We don't need a proof to confirm it. So measuring segments. When we measure segments, the distance between 2 points A and B can be written as the length of AB. Let's go to my pen here. There we go. The length of AB, and again, that's a segment, so we don't need the arrows. So the shorter way of writing that is if we just write AB, there's no line over it, that means the length of. So you'll see over here, it says AB without the line over it, and that means the length of. So if we look at this, A is at -1, B is at 3. So the distance between those 2 points is 4. And we would say then that the length of AB is 4. Okay, that's a little bit of notation. All right, congruent segments. So again, if we look at some segments on the right here, congruent segments, we would say if AB is equal to CD, the length of AB is equal to CD. So if the length of AB is equal to, there we go, CD. So now if we look over here, A is from -1 to 3, so that's a length of 4. And C is at -5, and then D is at -1. So the distance there is also 4. So since the length of those are the same, we can say that AB, segment AB, is congruent to CD. Congruent means equal to. The lengths are the same. And this is the symbol for congruent to. You're going to see that a lot moving forward. So AB is congruent to CD. Okay, so in these two segments here, MN and RS are the same length. They both have a length of 7 and 7. So since they are the same, we can say MN is congruent to RS. Now, sometimes you might see this first and not be given the information that they're both 7. So another way to indicate that their two segments are congruent is with tick marks, where you put a line like this. These are called tick marks, and that means the segments are the same length. So that means they are congruent. That's a shorter way to indicate that in a visual way. Okay. Now let's get to actually the segment addition postulate. Let's take a look at this and then think about it a little bit. If A, B, and C are collinear points, so on the same line, and B is in between A and C, so in between A and C, then this must be true. Then AB, the length of AB, plus the length of BC, so this segment plus this segment, should equal the whole thing. I don't know what happened to my equal sign there. There we go. Equals the whole thing, so the length of AC. Now that should make sense. If we take this segment here and this segment here and add them, I should get the whole thing. So yeah, that should make sense. Okay, so now let's just make sure with a couple of quick examples. So length of PQ is 9. So this segment is 9, and QR is 28. So that means, what is the whole thing? Well, if this is 9 and this is 28, we just have to add those two together. So 9 plus 28, that should give us 37. So PR is equal to 37. Okay. All right. So the other one says, well, use the same picture. I'm going to use the same diagram here. It says if QR is 17 and the whole thing from here to here is 21, then what is this? Well, PQ is unknown plus 17. That should give me 21. So that means 4. And you could do that in your head. So PQ, subtract 17 from both sides, and you should get 4. Hopefully that makes sense to you. That's the segment addition postulate. Okay, so now what they're going to do is sometimes bring in, rather than just having numbers, sometimes they're going to bring in some algebra. And so we're going to go through that. So this says if the whole thing, e.g., this whole thing here is 71 from here to here, then find the value of x. Well, we know this and this together, in other words, added together, has to equal this. So that's actually what we're going to write. We're going to write 8x minus 17 plus 5x minus 3. That better be equal to the total length, which is 71. So let's do that. Let's just get rid of this so we're not confused by that part. Okay, so here we go. Now, when I solve equations like this, I want to put the like terms together. So I want to combine this, and then I want to put this and this together. So let's do that. Okay, so 8x plus 5x is 13x. And then negative 17 minus 3 is negative 20. So all of this is just combined to be that. Okay. Now, that is supposed to still equal 71. Okay, so now I have condensed this a bit. So now I can just do a little bit of solving equations here. Add 20 to both sides. I get 13x equals 91. And then I want to divide by 13 on both sides. Okay, 91 divided by 13 is 7. Okay, so now I want to go back. What were they asking for? Here they said find the value of x. Okay, well, I just found it. I don't have to do any plugging back in. So x is equal to 7. Okay, cool. You always want to check to see if they ask you for something else, and you'll see that occasionally. And actually, kind of like this problem right here. Okay. So this time it says JL, which is the whole thing. So I'm actually going to write that. And we'll switch colors. So this whole thing is equal to 5x plus 2. It's helpful to write that in there so you just know exactly what you're dealing with. They want us to figure out what JL is, the whole length. Well, we know it's 5x plus 2, but we want to know the actual length. So this segment and this segment, JK plus KL, better be equal to this. So that's what I want to do is I'm going to write that. I'm going to say 27 plus 3x minus 1. That should equal the whole thing, 5x plus 2. Okay, so again, before we start doing anything, I want to make sure both sides are simplified. The right side is okay. The left side I want to combine 27 and negative 1. I want to put those together first. So 27 minus 1 is 26. So I have 26 plus 3x is equal to 5x plus 2. Okay, now I want to get all my variables on one side. So I'm going to move my x's to one side. So I'm going to get rid of 3x by subtracting 3x from both sides. These cancel. I have 26 equals 2x plus 2. Okay? Now, I want to subtract 2. Subtract 2. I have 24 equals 2x. Okay. And then divide by 2, divide by 2. So x is equal to 12. Okay, but they didn't ask me to find x this time. They asked me to find JL. So now what I want to do is plug back in. JL equals this. So I'm going to say, all right, cool. I now know that x is 12. So in place of x there, I'm going to put a 12. I'm going to add to 5 times 12 plus 2. So 5 times 12 is 60, plus 2 is 62. So now I know that JL is equal to that. So let's just say JL equals, the length of JL is 62. I'll put a box around that because that's my answer. Okay, so again, double check and make sure you're answering what they're asking for. In this case, they're asking for the length of JL. Okay. All right, let's talk about a midpoint of a segment. So midpoints are the very middle of a segment. So let's put some things in here. The midpoint of a segment is a point that divides the segment into two congruent segments. And remember, congruent means same length. So two segments that are the same length. Okay. A line, ray, or segment that intersects a segment at its midpoint is said to bisect the segment. And we call that a segment bisector. Bisect means cut into two. And in this case, they cut it into two so that it's exactly the same on both sides. So it's said to bisect the segment, and that is called a segment bisector, which should make sense. Segment bisector. Okay. So now, if we look at this diagram over here, it says in the diagram at the left, what is the midpoint? Okay, so you can see that AB and BC are the same because of the tick marks you see here. That means they're the congruent. So that means B has to be the midpoint. Okay, and it has to be the midpoint of that whole segment AC. Okay, and line L is the segment bisector. So line L, I'm going to do a script L there, is a segment bisector. Of AC. Okay, so midpoint and segment bisectors. Okay, so we're going to go through a couple that just hopefully make this make a little bit more sense. So if H is the midpoint of GI, find GH. So we know because H is the midpoint that this segment, I want my pen, there we go. This segment and this segment are the same. They're exactly the same. So I want to find GH, but in order to find X, I know that they're the same, so I can set these two segments equal to each other. So I'm going to say 5x plus 2. That we know that has to equal 9x minus 10, right? GH has to equal HI because H is the midpoint. Okay, so now I just want to do a little algebra. Get all your x's on one side. Again, it doesn't matter which one you get rid of. I'm going to get rid of 5x here, but it doesn't matter. I'm going to subtract 5x from both sides. If you got rid of 9x, that works too. I just do the 5x because I like positive numbers at the end. Okay, and then I want to solve for x, so I'm going to add 10. Add 10. 12 equals 4x. Okay, divide by 4. Whoops, not 3. Divide by 4. I was getting ahead of myself. Divide by 4. We get 3 equals x. Okay, now they don't ask for x here. They ask for what is GH. So I want to answer that, right? GH. GH, it says, is 5x plus 2 right here. So I'm going to say 5 times 3 plus 2. Ooh. That's a bad plus sign. Plus 2. There we go. All right. 5 times 3 is 15. Plus 2 is 17. So I know that GH, we want to write that out explicitly, excuse me, that GH equals 17. Okay. Hope that makes some sense. All right, let's try one more. All right. R is the midpoint of QS. Find the length of QS. Okay, so since R is in the middle, we know that these two segments have to be the same. So I'm going to do that same thing. And we're going to write 2x plus 16 is equal to 5x minus 17. Okay, so let's solve. Subtract 2x from both sides, or 5x. I get 16 equals 3x minus 17. Okay, and then I want to add 17 to both sides. Okay, and that's 33 equals 3x. These cancel out. Divide by 3 on both sides. So x is 11 this time. Okay, now I want to know QS, but they don't tell us what QS is. But I could just plug into one of these and then double it since they're both going to be the same. So let's just figure out what QR is first. So I'm going to change colors to make sure that that's QR would be 2 times 11 plus 16. Okay, so that's 22 plus 16, which is 38. Well, that's just here. So this segment right here is 38, which means this one is also 38, right? So 38 times 2, or 38 plus 38, however you want to think about it, is 76. So that means QS is 76. All right. Hope that makes some sense. Don't forget to write a summary in your notes, and then go ahead and get working on the segment addition postulate. Good luck. Bye.